Okay, this is Math 31, Unit 5, review and preview. I don't think we need to talk too much about intercepts. You've done so much of that, and I've said it so much, but symmetry is maybe not a new concept, but something that we don't talk a lot outside of calculus. And we're going to look at even symmetry and odd symmetry. Even symmetry is, parabolas, human beings for that matter. They look the same from left to right. Odd symmetry is a little harder to look at. What I'm going to do is I'm going to put up an odd symmetry function, and really what it is, I'll put it up first here. All right, so here on Desmos is really the easiest or simplest, I would argue, odd function, which is y equals x cubed. And that's when negative f of x is equal to f of negative x. And what odd symmetry is basically if we were to draw a line from a point to the origin, equidistant from the origin on the other side would be that point, or another point on the graph, I should say. And maybe I'll just include y equals x so we can see how that's happening. That if we look at y equals x, then I hope it's clear that, where y equals x hits up here, it is very symmetrical at this point. We can kind of see that symmetry as we look along the way. That's a really important consideration that, both of these functions have odd symmetry, and we say that that's symmetrical about the origin. Okay, just working through the examples now to determine whether each function is even, odd, or neither. I just want to put the conditions beside that because I think it's nice to see it, as we do it, that a function has even symmetry. Oops, sorry about that. A function has even symmetry if negative f of x is equal to f. Oh, that's the odd symmetry. Sorry. I'm going to fix that in a second. So this is actually odd symmetry. It has even symmetry if f of x is equal to f of negative x. Sorry about that. So the way that we check that is by just evaluating them. So f of x is equal to x to the power of 6. F of negative x is equal to negative x to the power of 6, which can be simplified to just x to the power of 6. So this does have even symmetry. That is absolutely correct. The other thing that we're going to check, we've done f of negative x. So now I'm going to check negative f of x. And that's a negative times x to the power of 6, which is negative x to the 6. So it has even symmetry, but negative f of x, which we just figured out, does not equal f of negative x. So this does not have odd symmetry. All right, for the next question, we're doing the same thing. We know f of x already. We don't have to reevaluate that. So negative f of x, I'll write that as negative x cubed minus 1 over x. And then we'll check f of negative x. Well, f of negative x is negative x cubed plus 1 over negative x. And that can be written as negative x cubed minus 1 over x. So to kind of summarize this symmetry, f of x was not equal to f of negative x. So it does not have even symmetry. But negative f of x was equal to f of negative x. So it has odd symmetry, or is an odd function. All right, they get a little bit uglier as the equations get, larger for sure. This third one, it's the final one, it's not too bad. I know they put y there. I'm going to immediately rewrite that. We'll use function notation almost exclusively. Is x squared over x cubed plus 4x minus 2. So f of negative x is negative x squared over negative x cubed plus 4 times negative x minus 2. So f of negative x squared is x squared, but this becomes negative x cubed minus 4x minus 2. Now, if you take a look at those two, they are not equal to each other. So it does not have even symmetry. I'm going to put a big kind of x through that. So the next thing we check is negative f of x. And negative f of x is just going to be a negative applied onto the entire fraction. Now, what we really want to check is if we can make negative f of x appear the same as f of negative x. And it's a bit of a weird concept, but I've certainly talked about it with you before, that I can write that fraction differently. I'm going to write this fraction as 1 divided by negative 1 times x squared over x cubed plus 4x minus 2. Just putting that bracket to show the distribution. This negative 1 would now distribute on, and I would have that negative f of x is equal to x squared over negative x cubed minus 4x plus 2, and we get so close. Negative f of x is almost f of negative x. But if you look closely, and unfortunately you do have to look closely, here we have positive 2, here we have negative 2. So it doesn't have odd symmetry either. So example C would have neither. And I don't want you to fall into the pitfall of thinking that questions are always even symmetry or odd symmetry. There are plenty of functions that have neither of those types of symmetries. So we have to get used to the idea that they don't always fit into one of those categories, which is pretty classic math for sure. Okay, that's the review and preview. I know we didn't do a lot with x-intercepts and y-intercepts, but hopefully you're pretty comfortable with that at that point because you've been doing them for, this will be your third or fourth year doing that. Do try the assignment and, stay tuned for the rest of chapter 5, which is curve sketching. Lots of fun, but definitely these questions can eat up a lot of space.